I really like cartoons. Welcome back to Shader Sundays, behind schedule as always. Today, we're going to be taking the first of hopefully many looks at Cel Shading. But what actually is Cel Shading? Cel Shading or Toon Shading is a type of non-photorealistic rendering designed to make 3D computer graphics appear to be flat by using less shading color. Basically, make shit look cartoony. With this technique, you can actually fine-tune the feeling you want to convey through color, which is very useful because you can show the whole world that you have absolutely lost touch with reality. Okay, let's begin, shall we? First, we need to choose our color scheme. If you haven't done this before, or you have absolutely no clue what color theory is, this will be the hardest step. But I'll try and simplify it nevertheless. You open your image editor of choice. I'll be using Krita, but the world is your oyster, use whatever you want. Starting with a canvas size. The height should be the number of distinct colors you want, and the width should be the number of shades. This number should be an odd number, because the base colors will be placed in the middle. Now, in my case, my canvas will be 9 white and 5 high. Pick your base colors and place them in the middle column. And now, let's start hue shifting. What is hue shifting, you may ask? I'm glad you asked. It's pretty simple, really. Your base color's hue shift towards blue for darker shades and towards yellow for lighter shades. It's as simple as that. Again, if you want to learn more about color theory and creating color schemes in general, I'll link some resources on the Git page. Now, open your preferred 3D graphics program. And as we all know, there's only one choice, and that is Blender. If you use something else, I'm sorry for you. First, you need to model your 3D model. And when you're past the modeling stage, comes the important part, UV unwrapping. How do we do that? We go to the UV editing workspace, and we select an area that we want to unwrap. Now, move your mouse to the image editor, press A, S, and then 0 to scale it infinitely small. Now move this dot to the color you want. It's as simple as that. And now, repeat this a couple of times till you have UV unwrapped your whole model, and you're done. Now, before we jump into Godot, let's assume that you're a hardcore Blender user and you don't want to leave your precious baby. Good news! You don't need to. I'm going to teach you how to cel shade inside of Blender. By the way, if I'm making wrong assumptions, feel free to skip ahead. Now, time to rip off CG matter. Open the shader editor, separate the principal BSDF from the material output, assign a volatility to the BSDF, take the UV coordinates, replace the X coordinate with the light value from the BSDF, sample the color scheme texture of those coordinates, and plug directly to the surface output. Now, change the mode from linear to closest. Bye-bye. Unfortunately, the time to leave Blender has come. Now, open Godot, add an environment because Godot's global illumination kind of fucks with the shader I'm going to show you. And now, import your 3D model as an FBX. In the material that comes with the FBX, we need to add a next pass shader material. And actually, finally, let's start writing some code. Luckily, Godot allows us to write light shaders, which are called for every light source, so we're going to be using them. First, we need to use the Lambert model to calculate the light value at the current pixel. And now, the essence of the shader is as simple as sampling the color scheme at the light value as a X coordinate and the UV's Y value as a Y coordinate. And voila, we have our beautiful shader. Thanks for watching, and I hope you actually learned something. If you did, again, it will mean a lot to me if you subscribe. Also, share this video with every single human being you know right now! If you want to. Also,